today, you might want a calculator if you don't have one. Grab one. That should be implied by now. But today we are talking about spheres and technically hemispheres. Sphere by definition, set of all points in space equidistant from a given point. This definition should sound familiar. Sounds like another definition that we've done this trimester. Previously, we had the set of all points in a plane equidistant from a given point, indicating two-dimensional sphere-like item. What's a two-dimensional sphere-like item? Circle. If it's on a plane, it's a circle. If it's in space, it's a sphere. Half a sphere? Hemisphere. Now, when you're talking about spheres and hemispheres, a couple things that you need to know. First off, you've got your center of your sphere. Cut that sphere in half. You got your hemispheres. There's two of them. But that place where you cut it across, that cross section of a hemisphere, is known as the great circle. When you do a cross section of a sphere, regardless of where that cross section is, it will always end up being a circle. But if you go through the one that goes through the center of the sphere, it's the great circle. And that great circle, it gives us a lot of information about our spheres and our hemispheres, because the great circle is where we look to find the radius of the sphere. The radius of the sphere is the radius of the great circle. Now, we're going to start with the surface area of a sphere. Now, if you take a sphere and you cut it up and you lay it out flat, you're going to end up with a kind of a weird shape. I'm not sure if you've ever actually seen, when we unfold like a globe and they fold it out, it doesn't make the flat type of maps that we actually see. That the maps that you see of a globe are really just kind of a modified version. That's why if you look at the longitude and the latitude, specifically I believe it's the latitude, goes north to south, you'll notice that on those flat maps it's curved because they have to adjust for that. Actually, when you lay out a sphere, its flat surface gives us a surface area of 4 circles. So 4 pi r squared. It doesn't perfectly go into circles when you cut it up nicely. But when you put it together, if you pieced it together, you would get 4 circles of the same radius as the great circle. Now, when we cut it in half, most people think, okay, so a hemisphere then must be 2 pi r squared. Except, when you cut it in half, the bowl part of that hemisphere is 2 pi r squared, but you get an additional flat face on it, an additional circle. So the bowl part is 2 pi r squared, the flat part is 1 pi r squared. Add those together and you get
2 pi r squared plus 1 pi r squared.
3 pi r squared.
AKA 3 pi r squared. Okay, so we're finding the surface area of some spheres and some hemispheres. What shape? Full sphere. We're looking for surface area, so 4 pi r squared is the formula we're looking at. We need the radius. Do we have it?
No.
We have the diameter, and how is a diameter related to a radius?
The radius is just 1/2 of the diameter.
Radius is half the diameter, or 2 times the radius is the diameter. So if 40 is 2r, r is
20.
20. So surface area 4 times pi times 20 squared. Now, much like previous situations, you can do an exact value on ones like this as long as your radius is an integer or a fraction. You just type in 4 times 20 squared. You'd get 1600, and don't forget to put the pi back on it. What kind of units would go on a surface area? Feet? Squared. Here's the thing. You don't have to do that. You can just type the entire thing into your calculator. 4 times pi times 20 squared. You get something around 5,000?
5,026.55.
5,026.55?
Yeah.
Yeah, about that.
Okay, perfect. I legit don't know what it is. I knew it was around 5,000 because I know 16 times 3 is about 48, and I kind of pushed it up. So, either of these is an acceptable answer. Problem B. Sphere, hemisphere, or a different shape? Hemisphere. Meaning my surface area formula has what number on it? 3 pi r squared. Give you a hint, it's a surface area. Areas are squared. That formula's got a square. I'm saying that because eventually we're going to get to volume. Okay, do we know the radius? Yep. So, surface area 3 times pi times 18 squared. I don't know it as an exact or a decimal answer.
972 pi units squared.
According to AJ, this is what it is.
I'm right.
I got that too.
Sweet. What if we wanted a decimal answer?
3,053.63
3,053.63 units squared?
Yeah.
Sweet. I'm hearing people say yes, so. Verifying. Good. Troutsy. Make sure that square is on the end, not on the floor. hemisphere, which means the formula has what number on it?
3.
3. So 363 pi meters squared, or 1,140.40 meters squared. Okay, last one on this page. Sphere or hemisphere?
What is her?
Sphere.
Sphere, full sphere.
Same thing.
So surface area is 4 pi r squared. If they were the same thing, they wouldn't have two different formulas and we wouldn't be talking about them separately.
Close enough, Nate.
Do we know the radius?
Nah.
No, but
Know the circumference though.
We know the circumference specifically of the, what's the big one called?
Circumference.
Of the great circle, and that's key. If this was not about the great circle, we wouldn't have enough information.
wait, why is it a great circle?
Because it's the circle that includes the center. It's the biggest circle.
That circle is great.
How do I find the circumference of a circle?
Circumference equals pi r squared.
No, that's area of a circle.
Circumference equals 2 pi r squared.
No, that's a modified formula that means nothing. If only there was like a page in our notes where we wrote down all the important things from chapter 11 that we would need, like on page 6 or something. It's either pi times diameter or 2 pi r. Which one makes more sense to use if I'm looking for surface area?
2 pi r.
2 pi r because I need the radius. So that means 12 pi is equal to 2 pi r. Remember, if you're given information like a circumference, you can always use circumference formulas, work backwards in order to work forwards on other formula. I want to get the radius. What's going to happen to the pi's? Death to them both because I'm going to divide by pi. Okay, so 12 is equal to 2r, which means the radius is 6. Surface area is 4 pi times 6 squared. Surface area is 96 pi feet squared. Somewhere around 300. I heard mumbling. I have no clue what.
452.39.
452?
Yeah. Wanna look in the 4 pi 6 squared, can you see?
Oh, because that's not 96. That's why. I screwed that up. That should be 144, shouldn't it?
Yeah.
That makes more sense. So 452.39 feet squared makes more sense. Okay. Let's talk volume. Volume of sphere also is dependent upon its great circle's radius. Formula for the volume of a sphere is 4/3 pi r cubed. What kind of units go on a volume? Cubed. Volume formula has cubed. Surface area formulas have squareds. Volume formula has cubed, at least with spheres. It's different with other shapes because of the fact that they're being multiplied by multiple variables. The only variable in this one is r. It has to go to the power that it needs to get to at the end.
Did you just use the same problems, but
Maybe. That one's different.
Yeah. Oh, literally the only difference. First thing.
Yes, most of them are the exact same. Because why not? Now, volume is the amount of three-dimensional space something takes up. By cutting it in half, it takes up half the amount of space. It's not like surface area, where surface area of a sphere you had to add on a top to the bowl once you cut the sphere in half. You don't have to add anything on to a volume. What is half of that formula? Yep. To divide a fraction in half, you don't divide both the top and the bottom. You don't divide by the denominator, because if you divide the denominator, you're actually ending up multiplying it by something.
2/3?
2/3.
No.
Pi r cubed. That's why we sat here for a bit, because a lot of y'all are like, fractions, no. Fractions, yes. Fractions, good.
No fraction.
Yes, fractions. I should make every question on the final have a fraction.
Yeah, you
Please.
should.
No, please.
And make you answer in a simplified fraction form.
No, please don't do that, please.
No.
Please don't do that.
Okay,
How
I
many
won't.
points is the final 30 words?
It's
100.
we didn't do it on
Same
the
as
final.
typical test.
Oh.
Okay. Anyway, next one. Find the volume of the solid. Round your answer to the nearest hundredth. Guess what? This is still a sphere. I know. On the previous page, we called it a sphere, and for some reason, it did not decide to change itself. I know. Pictures. You'd think they'd, have an opinion and change. Okay, so volume is 4/3 pi r cubed. Guess what? We still don't have the radius directly, but we calculated it earlier because earlier we found out we were given the diameter, and the diameter is 2 radii. Therefore, our radius is still 20. No. Volume equals 4/3 pi times 20 cubed. Now, exact answers for volume can work too, but the 4/3 complicates when this will work out nicely. If the radius is an integer, you can write an exact answer, but it's going to be a simplified fraction unless the radius is divisible by 3. Does 20 divide by 3 nicely? No. So if you want to do an exact answer, your exact answer is going to include a fraction. Fraction's good, right?
No.
Do you have to do the exact answer? No, you can just type it into your calculator. How the heck do I type in 4/3 into a calculator?
4 divided by 3 in parentheses.
4 divided by 3. Fraction bar is just a divide symbol. You generally do want to make sure it's in parentheses. I'll be honest, if you don't on these ones, it's not going to be the end of the world. PEMDAS is working in your favor here. 33,510.32.
Yeah.
What's?
B cubed.
B cubed.
How many points is our final?
Well, she just said it.
Like 5.
She literally just said it.
Oh man, I wasn't listening.
It's 100. Like every other test.
100 points.
She said 100 points like every other test.
Okay. Sphere or hemisphere? Hemisphere. You can do exact answers for hemisphere as well, but they're going to have that same complication. Either you're going to have a fraction unless the radius is divisible by 3. Does 18 divide nicely by 3?
Yeah.
Sweet. This one we could do an exact answer and it would be nice and easy to work with. So if you want, you can do the exact. You type the 2/3 times the 18 cubed, do 2/3 into a calculator. 2 divided by 3 in parentheses. Again, on these ones, without the parentheses, it'll actually work out fine, but be careful. Won't always work out fine. How do I put a power of 3 in my calculator?
The triangle.
For many of you, it's the up symbol. For some of you, your calculator has like a that symbol. For some of you, your calculator has like a that symbol. But yeah, if you don't know how to do that on your calculator, you better be asking. My exact answer. Yes, 3,888 units cubed.
You forgot the pi.
Don't forget the pi. If you're gonna do exact and you forget the pi, it's wrong. When in doubt, don't do exact. 12,214.51
Yeah.
units cubed. We're gonna skip over words. I can words. We're gonna skip C.
Word moment.
I know, right? D. We've done one like this already.
Yeah, we did.
We have the circumference of the great circle. How do I do that if I'm not given, like, the radius?
Circumference is equal to 2 pi r.
If you're not given the radius, you're always just looking for the formula that connects what you were given to the radius. We did the same thing on diameter. Many of you just don't think about it as doing the same thing because it's such an easy formula to work with. But you're doing the same thing. Technically, when you're saying divided by 2, you're technically recognizing that diameter equals 2 radius and dividing by 2 because of that. Six equals 2 pi r. Don't forget the pi. Divide by pi and they cancel. Then I divide by 2 and the radius is? 3. Sphere or hemisphere? Sphere. 4, 3, 4/3 or 2/3?
4/3 pi 3 cubed.
4/3 pi r cubed. Volume formulas for spheres have a cubed on them. Could I do an exact answer on this one?
Perchance.
I could. Now, some of you have been going through and doing this and you're doing the calculations before typing it into a calculator, which is perfectly fine. But a common mistake I see when people do that, can I just cancel out these 3's right now? No. Because the 3 is cubed. All you technically did was cancel out one of the 3 3's that are sitting there. So be careful of that. Okay, 4/3 pi r cubed. 36 pi? Yes, no, I did that in my head, so don't trust me. We saw how that worked out on the previous page.
Yeah.
36 pi centimeters cubed, or 100.10 centimeters cubed. Okay. Last thing you're going to see is some working backwards problems. Now, the working backwards problems are the problems that most commonly caused issues on the quiz. In any situation where you're working backwards, you identify the shape first. Sphere. You identify what I told you about the shape. I'm telling you a surface area, so you find the formula from that shape that works with that idea. Sphere's surface area formula. Surface area equals 4 pi r squared. You recognize the formula, you plug in what you know. You good over here? Are you good?
Yeah.
Yeah, he's good.
You sure?
Yeah, I'm sure.
You're acting weirder than normal.
Boom, roasted.
Not really, it wasn't really that big of a thing. You plug in what you know. Now, on ones like this, there's fewer things to know, and so it's not so bad. We're going to talk about the ones that were on the quiz that stumped some of y'all. Many of you set up the formula beautifully and then couldn't solve it. So we had to address that too. Okay, I'm going to solve this. What am I getting rid of first?
You should get rid of the pies first.
I would get rid of the pi's first because I'm going to divide by pi, and that cancels nicely. I square root it next, right?
No.
No. You do not take the square root until the r squared is alone. That was a common thing that popped up on the chapter 11 test with the work backwards problems. Divide by 4 first. 36 equals r squared. To get rid of the squared, you take the square root. When you take a square root, you technically put what in front of it? Symbol, positive, negative, plus or minus. Do I need that with a radius?
Nuh-uh.
No, what's the radius?
6.
And if you tell me it's 6, it's wrong.
It's
Pi. 60 centimeters.
Centimeters, not pi. We got rid of the pi. The pi died. Okay. Next example. What shape?
Sphere.
Sphere. What did I give you?
Surface area.
Surface area. Now I want diameter. Do I have a formula that connects a sphere's surface area to its diameter? No. I have one formula for surface area, so that's the one I'm using regardless on if it's going to get me to the correct thing or not. Because once I get to whatever it gets me to, I can modify it to go to the correct one. It's just like this. Sometimes I have to solve and work backwards to work forwards. The only sphere surface area formula I have is this one. So that's what I'm going with. Easiest thing to get rid of first? Pi. If there's pi on both sides of these equations, kill the pi's. Divide by 4 before square rooting. Now, when you divide by 4, I get a decimal that's bigger than hundredths.
Yeah.
But
Hit the
don't
thing.
round until you get to a final answer.
Yeah.
That's not that hard to write down that entire number. 5.0625 equals r squared. Square root. And the nice thing, even if it was an ugly number, remember on your calculators, you can always plug in the previous answer. I click the square root symbol, I hit second and the negative symbol, and it puts the previous answer in.
Alright.
2.25.
We're not done.
No,
Why not?
Chase.
We gotta find the circumference.
No, I don't.
We're gonna
No, you have to find the diameter.
I have to find the diameter.
Multiply by 2.
Yeah.
Multiply it by 2. 2.25 times 2.
5.
Try again.
4.5
4.5.
4.5. And if you put that, you're wrong.
centimeters squared.
No,
No, centimeters.
Centimeters.
no further, it's fine.
I'm scared. 2.25 times 2 is 5. Diameter and circumference apparently are spelled the same. centimeters squared for diameters. I'm scared right now.
Listen.
That's okay. We'll lock in for the test.
I don't doubt you will.
Oh, then I forget there are centimeters.
That's it.
Final one.
Ow.
Oh my god.
Word problem.
I'll give you a hint about these word problems. They're the exact same as the non-word problems. I just don't give you a picture.
Pictures make it better.
Basketball.
I tell you it's a sphere. If I tell you it's a sphere, how hard is it to identify the shape?
Not hard at all.
It shouldn't be hard. That doesn't change the fact that on the Chapter 11 test, when I told you some of them was a rhombus, you still use the trapezoid formula.
That was probably me.
But it's a sphere. I'm telling you it has a volume. What formula are we using?
The,
We're gonna use the
Four-
4 divided by
four-
3 pi r
that
cubed.
one.
4/3 pi r cubed, because it's volume for a sphere. Okay, I'm telling you the volume is 288 pi.
Yeah, it is.
Plug in what I know. First thing you get rid of is still the same. It's still the easiest thing to get rid of. It's the pi.
Well, that's an unfortunate situation.
How do I get rid of 4/3?
Times it by 3/4.
Times by 3 and then divide by 4 if you'd like, or multiply by 3/4 does it all in one step.
Yeah.
I don't care if you do it in multiple steps. I don't care if you do it in one step. I personally like the one step option. $126? No, that's not right.
216.
216.
Yeah, I inverted my
Close.
1 and my 2. I'm like, wait a second, that's not right. 216 equals r cubed. How do we get rid of a cube?
You have to go to math, and then
You have to go to
like the math setting on a calculator, and go down to mine. It says -4,
not do
where it's gonna give you a little.
Sigma.
What's that symbol called?
I don't know what it's called. My sister taught me it though.
Here, I'll give you a hint.
The square root, like.
It looks like a square root symbol because
Oh, it's the one with the X on it.
square roots get rid of squares, right?
Yeah.
Wow.
What kind of roots get rid of cubes?
Oh,
Cube
the
root.
It's
cube
cube
root.
root. So we're gonna take the cube root. A cube root looks like a square root symbol, but has a little 3.
What the sigma?
A little 3. In all technicality, square root symbols have the same idea.
I think I figured it out.
A square root symbol technically could be written as a square root symbol with a little 2 right there.
Miss Benson, where is it?
Dad,
Where
is
is
that?
it?
Did I do that then? Is the answer
So let's
6?
talk about where to get it.
What the
Is the
sigma?
answer 6?
Oh, do we do all
Oh, I
three in
did
the
it
square
right.
root?
Where to get it depends upon your calculator.
TI.
There are a couple, there's multiple TIs.
The little TI.
This one.
TI
I know
plus.
Okay.
how to do it.
Where to get it.
I have the
Jeez.
answer.
I would have been done explaining by now if y'all quit interrupting me. Like, seriously. Okay, where to do it. Where to find it. Now, on your calculator, depending upon which calculator you have, you might be looking for 2 different symbols. Some calculators have a symbol that actually looks like that. Some calculators have a symbol that looks like this. This is specifically cube root. This is any root you want. For some of you, you'll see this directly on your calculator, and typically it's opposite of the power button. So find your power button and you'll see right above it the little X root symbol. If you're doing this one, the first thing you do is you type in the 3, then you type in that button, and then you type in your 216. So my Casio actually has both. I click 3, shift to get to that button, Now mine's fancy and actually makes it look like a cube root. Many of you, it will just stay looking like this. 216, enter, there we go, it's 6. If you have a graphing TI calculator, you have both of those buttons as well under the math button. Click math. The fourth option is a cube root, the fifth option is the xth root. If you're using the xth root, again, you're going to have to have clicked 3 first and then gone to that one. If you're doing a cube root, just click the cube root button, then do 216. Either way, our radius is 6. By the way, when you do a cube root button, the plus or minus is not a thing. Even if it wasn't a radius, because when you cube a number, it doesn't automatically make it positive. Squaring a number does. That's why it needs the plus or minus, because there's 2 different results that could have gotten us there. Cubing a number does not. Don't forget your units. If you're not sure how I got that, if you need help with your calculator, please ask me during work time. Now, your homework today. I'm guessing most of you, unless you are a huge fan of bookwork. How many of you are a huge fan of bookwork? Anyone? Yeah, that's what I thought. All of you need to be thankful to Miss DeBoer, because she made a worksheet.
Yeah, Mr. Board. Yeah.
It wasn't supposed to be a worksheet. I haven't written down any of the homework for this chapter. I hope you have.
No.
Yeah, it's my mom's birthday.
Today is the 22nd. Our homework's due on Friday.
I will make sure. Yeah, no.
What's happening Friday?
Test.
What do you get to use on the test?
Every
Note card.
3" by 5" note card, both sides. I've got note cards up here if you want them.
So next week are we taking the final on Wednesday or Thursday?
You guys